Stephen Hawking, The Grand Design. Embark on a fascinating journey through space and time as we explore the very origins of the cosmos in The Grand Design by the mastermind Stephen Hawking. This book summary will take you on an enlightening voyage through the depths of scientific inquiry, fathoming age-old questions about existence, life in the universe, and the timeless debate on free will. By exploring the fundamentals of scientific determinism, the limits of human perception, and the search for a grand unified theory, embark on a thought-provoking adventure that raises profound insights into our understanding of reality and our place in the universe.
From mythology to science. The history of scientific inquiry began by challenging mythological explanations for natural occurrences. This overview follows the evolution of scientific methods from ancient Greece to Isaac Newton and beyond. Human curiosity has driven our desire to understand the mysteries of our world and universe for thousands of years. In ancient times, we used gods to explain natural phenomena such as the sun, rain, thunder, earthquakes, and volcanoes. We believed that if we could please the appropriate gods, we'd have good weather, and if not, natural disasters befell us. It took ancient Greek philosophers like Aristotle, Archimedes and Thales to move us past this mythological thinking, putting them at the forefront of pondering the universe and exploring life's big questions. From there, the Greeks began to find new ways to understand the world apart from godly intervention, paving the way for individual thinkers like Archimedes who conducted experiments, carefully measured and observed their results, and deduced the lever principle. This foundation would continue evolving to become the scientific method, a strict system of formulating hypotheses and rigorously testing them through experimentation, measurements, and observation. In the 16th and 17th centuries, scholars like Galileo, Johannes Kepler, and René Descartes were early proponents of the scientific method. Isaac Newton's use of this system led to the formulation of the laws of gravity and motion, allowing us to understand the movements of planets and stars. Eventually, the scientific method would help explain the workings of everything in the physical world and give rise to scientific determinism, the expectation that each occurrence in nature can be scientifically explained, including human decisions. The history of scientific inquiry began by challenging mythological explanations for natural occurrences. This overview follows the evolution of scientific methods from ancient Greece to Isaac Newton and beyond. The science of free will. The debate about free will has been a long-standing one within the world of philosophy, leaving many to question whether we truly possess it. René Descartes believed in the separation between human body and soul, stating that the soul is the source of our free will. However, this idea raises numerous queries among scholars, especially in the context of scientific determinism. Recent advancements in neuroscience reveal that all of our actions and decisions are governed by biological and chemical laws. As a result, it is challenging to discern whether free will exists in all living things or whether it is restricted only to humans. The fundamental truth is that every choice we make can be explained through biological mechanics, much like any other organism around us. The illusion of reality. Our perception of reality is subjective, with no one definitive version of reality. The truth is that what we see is a mental image created by our brains based on the information sent by our senses. The laws of science that we accept as accurate have been created by people with the same senses we have. Therefore, other living organisms' realities are no more or less valid than our own. The notion is supported by the Italian city of Monza's council outlawing curved fish bowls in 2004, claiming that its curved glass would distort the fish's vision, leaving them to live in a cruelly distorted reality. However, if one acknowledges that their reality isn't distorted and that there's only one accurate reality to exist, they'd be presumptuous. Our reality could still be an illusion or deception from an individual's experience. Even a goldfish's reality within a curved fishbowl could be as accurate as ours, and it could formulate scientific laws that accurately reflect its experiences. The 4 criteria for a good theory. In the search for a good theory, 4 key criteria must be met. Firstly, it must be elegant. Secondly, it shouldn't depend on too many adjustable or random factors. Thirdly, it should explain every existing observation. Lastly, it must contribute to future observations and predictions. While elegance may be subjective, an elegant theory simplifies a complex subject. A good theory must also not require additional elements to make it work. It should explain a phenomenon scientifically. Finally, a good theory must predict future observations. A theory that meets all four criteria is reliable. The astonishing quantum world. At the subatomic level, quantum physics defies our perception of normality. The uncertainty principle, established by Werner Heisenberg, explains that we cannot know the position and velocity of a particle with precision. Instead, we can only measure the probability of its position. Moreover, the act of observation itself affects what we are observing. Quantum theory also highlights the difficulty in conducting experiments on the subatomic level due to the disruption caused by even the smallest sources of energy. Einstein's theory of relativity. Einstein's groundbreaking theory of special relativity transformed the understanding of time and its dilation at different velocities. The constancy of the speed of light, regardless of motion, proved that space and time are interconnected, forming the fabric of the universe, also known as spacetime. The theory of general relativity explained gravity as the curvature of spacetime, where the weight of a massive object creates a distorted path that smaller objects follow. Einstein's revolutionary theories reshaped modern physics, opening up a new understanding of the universe and the fundamental forces that govern it. The quest for a grand unified theory. Physicists have long sought a grand unified theory, GUT, that would merge the four fundamental forces of nature. However, all attempts at creating a GUT have been unsuccessful, as experiments have continuously disproven proposed theories. The M-theory, a collection of multiple theories working together, may be the answer. Unlike traditional attempts, M-theory suggests the likelihood of multiple universes. It proposes the existence of a whole range of other universes, and it was fortunate that our universe is fit for life. The universe's origin and Earth's place. The origin of the universe has been a controversial topic, tackled by those who believed it was the work of God and those who thought it always existed. However, modern science has been able to explain how the universe began and expanded while following the laws of nature. Edwin Hubble's discovery in 1929 showed that the universe was expanding, and scientists were able to trace it back to a point just before the Big Bang. It was also discovered that the Earth was located in the habitable zone, a perfect distance away from the Sun for life to exist. While some believe this is due to intelligent design by God, most scientists believe it was a matter of luck and a combination of different factors.
In conclusion, the grand design invites us to ponder the intricate interplay between scientific laws, human consciousness, and the nature of reality itself. By examining the development of the scientific method and its implications on our understanding of free will, Stephen Hawking demonstrates that there is no clear line separating what is subject to scientific law and what possesses a magical, free will. The theories of relativity and the uncertainty principle show us that our comprehension of the universe is intimately linked to our own position in it. The search for a unifying theory such as M-theory highlights our enduring desire to understand the cosmos and our place within it. Ultimately, we are encouraged to appreciate the sheer luck and cosmic fortune that has allowed us, Earthlings, to exist in a universe so vast and mysterious.